Ever stop to think about how we got from these giant room-sized calculators to the super sleek devices we all carry around in our pockets? It's pretty wild. Well, today, that's exactly what we're going to dig into. We're going to break down the fundamentals of what makes a computer, well, a computer.
I mean, think about it. You're using one right now. They're everywhere. Our phones, our laptops, even our cars are packed with them. So let's just start with the most basic question, right? What is a computer, really? Okay, so at its absolute core, it's pretty simple. A computer is just an electronic device that manipulates information. It can store it, get it back later, and process it. You know, whether you're sending an email, playing a game, or plugging numbers into a spreadsheet, it's all about taking in data, doing something with it, and spitting out a result. So here's the game plan for today. First up, we'll nail down what a computer actually is. Then we'll meet its whole family. And trust me, it's a big one. After that, we're going to peek under the hood to see how these things really work. And finally, we'll do a quick trip through time to see how they've evolved.
All right, let's jump right into our first section. That definition we just talked about sounds pretty straightforward, right? But the sheer variety of machines that we call computers is, well, it's huge.
Okay, so how do we even begin to sort all these different machines out? Well, you can basically categorize them in three main ways. You've got mechanism, which is about the kind of data they crunch. You've got purpose, which is, what they're actually built for. But for our tour today, we're going to stick with the one that makes the most sense to start with, size.
All right, time to meet the family. We're about to go on a little journey, starting with the absolute biggest, baddest machines on the planet, all the way down to the tiny thing that's probably in your hand right now.
And leading the pack, we have the titans themselves, supercomputers. These are, no joke, the biggest, the fastest, the most powerful computers on Earth. They're built to solve problems that are so ridiculously complex, nothing else can even touch them.
So what kind of problems are we talking about here? Well, how about forecasting the exact path of a hurricane, or running a simulation of the Big Bang? Yeah, or managing the entire Bitcoin network, or even creating flight simulators so realistic that pilots can train on them. This is the heavy, heavy lifting that supercomputers handle every single day.
Okay, next up in the family tree, we have the mainframe. Now, if a supercomputer is like a Nobel Prize-winning scientist crunching one massive problem, a mainframe is like the CEO of a giant global corporation. Their whole deal is reliability and handling just an insane volume of transactions all at once. You know when you check your bank account, or use your cell phone, or when a hospital pulls up your records? Yep, there's a very good chance a mainframe is in the background making all that happen. They're these invisible workhorses that let thousands, even millions of us access the same data at the exact same time, and they do it securely.
So here's the main difference, right? Think of a supercomputer as a world-class sprinter. It's built for one thing, pure, raw speed on one incredibly complex task. A mainframe, on the other hand, is like the air traffic control system for a massive airport. It's a generalist, built to juggle thousands of different things for thousands of people all at the same time without ever dropping the ball. So, specialist versus generalist, raw power versus rock-solid reliability.
Okay, let's scale it down a notch to the mini-computer. So if the mainframe is the CEO, you can think of the mini-computer as the department manager. It's not running the whole company, but it's still pretty powerful. It's designed to serve a bunch of users in one place. We're talking anywhere from maybe 4 people up to a couple hundred.
So you might find one of these running a specific department, like handling all the billing and accounting, or maybe controlling the automated robots on a manufacturing line. They were a really crucial stepping stone, kind of the bridge between those giant mainframes and the personal computers that, well, were about to change the entire world.
And that brings us to the one we all know and love, the microcomputer. This is it, the personal computer, the desktop, the laptop, the machine that was built just for you. This was the big one, the revolution that literally put all this computing power right into our homes and onto our desks.
So what was so revolutionary? It was all about accessibility. For the first time, you had a machine that was small enough, cheap enough, and easy enough for a regular person to use. No special training needed. Suddenly, you could do everything from writing a paper to watching a movie. This was truly the computer for everyone else.
Okay, so we've met the whole family, from the giants to the ones in our pockets. But what did they all have in common? Well, no matter how big or small, every single computer runs on 2 basic things, hardware and software.
Let's start with the hardware. Easy enough, that's all the physical stuff you can actually touch.
You've got the brain, which is the CPU, or central processing unit. You've got memory to store things, and you've got ways to talk to it, like your keyboard, and for it to talk back, like your monitor. This is the physical body of the computer, the bones of the machine.
But here's the thing. Hardware is just a useless pile of plastic and metal without software. The software is the set of instructions that tells the hardware what to do. And this diagram here, it shows it perfectly. Right in the middle, you have the hardware. The next layer out is the system software. Think Windows or Mac OS. It's like the manager of the whole operation. And then, on the very outside, you have the application software. Those are the apps you actually click on and use every day.
So, the big question is, how on earth did we get from machines that took up an entire room to something that fits in the palm of your hand? To answer that, let's do a super quick tour through the 5 generations of computing.
See, each generation is marked by one huge technological leap. It didn't just make computers faster, it completely changed them. So we start with these massive, clunky vacuum tubes. First generation. Then came the second generation with the transistor, a tiny little switch that let computers shrink down. Then, the third generation gave us the integrated circuit, which crammed hundreds of those transistors onto a single chip. Now we're talking desktop size. And finally, the fourth generation, the microprocessor, that put the entire CPU, the whole brain on one tiny chip. And that's what brought the computer into our homes.
And wow, this picture just says everything, doesn't it? On the left, that's a vacuum tube. You'd need thousands of those for just one of the early computers. And on the right, that's a microprocessor. It has millions of transistors packed into a space smaller than your thumbnail. I mean, the leap from one to the other is just, it's mind-boggling.
And that brings us right up to today, to the 5th generation. And this one's different. It's not just about getting smaller or faster anymore, it's about getting smarter. This is the age of artificial intelligence, of AI. We're talking about computers that can actually learn, that can understand what you're saying, and can even beat the world's best players at the most complicated games you can imagine.
So there you have it. From these absolute giants that filled rooms to the tiny geniuses in our pockets powered by AI, the journey of the computer has been absolutely incredible. And it all leads to one final huge question, doesn't it? If this 5th generation is all about AI, what in the world is the 6th generation going to look like? What's next?